morning, everybody. I am V.R. Seshagiri Rao, Associate Professor in the Department of Electronics and Communication Engineering. Today, I am going to deliver a lecture on Principle of Operation of BJT. The references for figures and the content I have taken from Millman and Christo C. Halkias Integrated Electronics textbook. So, introduction. During the period 1904 to 1947, vacuum tubes were popularly used in all instruments, in all electronic devices. And the vacuum tubes, it had a cathode which emits electrons, and cathode is heated by a filament. And for the cathode to emit electrons, it has to be heated for some time. So there used to be a warm time. So there used to be a delay. So all the devices which used vacuum tubes, they were slow. They were not ready for action immediately after switched on. And moreover, they were very bulky also. And they were not reliable. So we had vacuum diode, vacuum triode, vacuum, etc. and all that. And on December 23rd, 1947, Walter H. Britton and John Burdeen, they demonstrated the amplifying action of the first transistor, which is called the BJT, bipolar junction transistor, at Bell Telephone Laboratories. So this is a revolution, and the advantages of this BJT is that it was very smaller and lightweight, and it had no heating requirement or heat loss, and it had a rugged construction with more reliability. And all the devices so far we discussed are, let it be Zener diode or p-n junction diode. They are two-terminal devices, but the transistor is a three-terminal semiconductor device which regulates the current or voltage flow between the two terminals. And the third terminal, it acts as a control terminal, or it acts as a gate for the signals. So the transistor is a three-terminal semiconductor device which controls the current or voltage flow between two points. So why do we need transistors? Suppose you have a FM receiver. So the FM receiver, let's say, grabs the signal, and the received signal, let us assume that it is weak due to the atmospheric disturbances. So if this signal is received at the receiver, we cannot hear because the signal is weak. It is already corrupted by noise. So what we need to amplify the signal against the noise, and amplifying means increasing the signal strength. So for amplification, we need the transistor. So amplification is needed whenever the signal strength is to be enhanced, and that is done by a transistor. It can be a BJT or it can be a FET, anything. So the transistor also can be used as a switch to choose between available options, and it regulates the incoming current and voltage of the signals. So amplification is required whenever the signal strength has to be increased, and this can be done by a transistor. And alternatively, the transistor can be used as a switch also to regulate, to control the incoming current or voltage. Now let us see the construction details of the transistor. So the transistor is a three-terminal device, and this is formed by connecting two diodes back to back. So it has got two p-n junctions. So I'll take a transistor and I'll show you a diode equivalent to the transistor. Then you can understand that the transistor is nothing but two diodes connected back to back. So when there are two diodes, each diode has one junction. So when there are two diodes, there are two p-n junctions. So three terminals are drawn out of the semiconductor materials present in it. This type of connection offers two types of transistors. So what are the two types of transistors? We have NPN transistor or PNP transistor. So in NPN transistor, P-type material is sandwiched between two N-type materials. In PNP transistor, N-type material is sandwiched between two P blocks. So you can see here, P-type material is sandwiched between two N-type blocks in NPN transistor, and in PNP transistor, N-type material is sandwiched between two P-type blocks. So the construction of the transistors are shown here, and the three terminals are nothing but emitter, base and collector. These are the three terminals in the case of a transistor. So in the case of NPN transistor, emitter and collector are made by N-type material and base is made by P-type material. In case of PNP transistor, emitter and collector, they are of P-type and base is of N-type for PNP transistor. Now this is the symbol for the NPN transistor. So NPN transistor is represented this way. This is collector as shown here, and this is base and this is emitter. And the direction of arrow, it indicates the direction of current when the junction is forward biased. So similarly, the PNP transistor, the direction of arrow is inside. So when base to emitter junction is forward biased, the current is towards the base terminal. And in case of NPN transistor, when base to emitter junction is forward biased, the flow of conventional current is away from the base terminal. So the arrowhead in this above figures, they indicate the emitter of a transistor. So as the collector of a transistor has to dissipate much greater power, it is made large. So the emitter, it emits. The name indicates that it emits. Emits what? It emits the charge carriers. And collector, it collects whatever charge carriers are produced by the emitter. So due to the specific functions of emitter and collector, they are not interchangeable. So both of them may be of P-type in case of PNP transistor, but you cannot interchange the P-N type emitter with P-type collector. They are not interchangeable. They are made with for a specific function. Now let us see what are the functions of these three terminals: emitter, base and collector. So in emitter, the left hand side which is shown, the structure is known as the emitter, and it is moderate size and it is heavily doped, and its main function is to supply the majority charge carriers. Suppose if you take NPN transistor, the majority charge carriers are electrons. So in the case of NPN transistor, the emitter supplies electrons. Suppose you take a PNP transistor, the emitter is P, so the emitter supplies holes, because the holes are majority carriers in the PNP transistor. So as it emits electrons, it is called as the emitter. So it is designated by the letter E. So this is, let us take that this is the PNP transistor, and this is emitter, and this is base, and this is collector. So here in this case, the emitter produces holes, because holes are majority charge carriers in this P-type region, and the holes are collected by the collector. Now let us come to the base. So the middle material which is sandwiched between the outer layers is nothing but the base, and the base is very thin and lightly doped, and its main function is to pass the majority charge carriers from the emitter to the collector, and base also controls the flow of current from the emitter to the collector, and base is designated by the letter B. So base is very thin and lightly doped, and its main function is to pass the majority charge carriers from this end to the other end. Means this is emitter and this is collector. Now collector, as the name indicates, it collects whatever the charge carriers are emitted by the emitter. So the collector, which is on the right side, so it collects the charge carriers. As the name implies, its main function is to collecting the carriers, and it is a bit larger in size than the emitter and base, and it is moderately doped. So this is indicated by the letter C. Now, when a transistor, when it is connected in a circuit, 4 terminals are required. Why 4 terminals are required? You require 2 terminals for the input signal, and we require 2 terminals for the output signal. So you require 4 terminals. So when a transistor, when it is connected in the circuit, 4 terminals or leads or legs are required. So 2 both for the input or output. So the transistor have 3 terminals. So this situation can be overcome by making 1 terminal common to the both input and output. Transistor has only 3 terminals, emitter, base and collector. So where from we get the 4th terminal? So 1 terminal is made common to the input and output. So we get 4 terminals. So when 1 terminal is common to both input and output, we have 4 configurations. So what are the 4 configurations? Common base configuration, common emitter configuration, and common collector configuration. So in common base configuration, base is common to the input and output. In emitter configuration, emitter is common to the input and output. In CC or common collector configuration, collector is common to the input and output. And for these 3 modes, common base, common collector, and common emitter, there are 3 regions of operations. So what are the 3 regions? Cutoff region, saturation region, and active region. So we have to supply the DC voltage to the NPN or PNP transistor so that the transistor can operate in one of these regions. So transistor operates in any one of these regions depending upon the polarity of the DC voltage. So applying DC voltage means we are biasing the transistor as per the requirement. So here we know we have 2 junctions, base emitter junction and collector junction. So base emitter junction we call it as the emitter junction, and base collector junction we call it as the collector junction. Okay. So when the emitter is forward biased and collector is reverse biased, we say that the transistor operates in the active region. And if emitter is forward biased and collector also is forward biased, we say that it is operated in the saturation region. And when both junctions are reverse biased, then we say that the transistor operates in the cutoff region. And when emitter junction is reverse biased and collector junction is forward biased, we say it is inverted. This is normally not used. So we have 2 junctions. Let us take this is a PNP transistor. This is emitter terminal. This is base terminal, and this is collector terminal. Now in this case, this is called as the emitter junction, and this is called as the collector junction. So emitter junction means it is a junction between the emitter and base. Collector junction means it is a junction between the collector and base. So if we apply positive voltage to P and negative voltage to N, that means this junction is forward biased. Similarly, if we supply forward voltage to P and negative voltage to N, then we say that the collector junction is forward biased. So when both junctions are forward biased, it acts in the saturation region. And when emitter junction is forward biased, that means we apply positive voltage here. And when collector junction is reverse biased, that means we apply a negative voltage here. Then the emitter junction is forward biased, collector junction is reverse biased. We say that the transistor is placed in the active region. And when both junctions are reverse biased, that means when we apply a negative voltage here and here also when we apply a negative voltage, that means the transistor operates in the cutoff region. So these are the three regions of operation: cutoff region, saturation region, and the active region. Now let us come to the cutoff region. So this is the transistor, NPN transistor. So cutoff region means, just now we discussed, both are reverse biased. So this is NPN transistor. We apply a positive voltage here and the base is made negative with respect to the emitter. So this is reverse biased. This junction is reverse biased. And here also we are giving a positive voltage to N and negative voltage to P. That means this also is reverse biased. So J1 is reverse biased and J2 is reverse biased. So we say that the transistor is in the cutoff region. Suppose if you use the transistor symbol, then it is like this. The NPN transistor, so the arrow of the current is outside. So we are applying a positive voltage here and a negative voltage here, and here we are applying a positive voltage here and a negative voltage here, and this common point is grounded. Now what we call this configuration? You see here the base is common to the input and output. So this is a common base configuration which is placed in the cutoff region. Now let us see the saturated mode for the same transistor. So saturation region means both junctions are forward biased. So we apply a negative voltage here and here also we apply a negative voltage. So J1 is forward biased and J2 also is forward biased. So we say that the transistor is placed in the saturation mode or the saturation region. Now what is active region? Active region means we make the emitter junction forward biased but collector junction reverse biased. So that is nothing but the active region. So in this mode, one junction, that means the emitter junction is forward biased and the collector junction is reverse biased. You see here, we are applying a negative voltage here and this is a positive voltage. That means this is forward biased. But here, to the collector terminal which is of N type, we are applying a positive voltage here and this is a negative voltage. So this is reverse biased. So this is placed in the active region. And active region is used for amplification purposes. We use the transistor for amplification when it is put in the active region. Suppose you take a PNP transistor. How to place a PNP transistor in active region? It is like this. So this has to be made positive because the emitter junction has to be forward biased. Emitter, base and collector. And collector we have to supply the negative voltage because we have to reverse bias it. So this is how we can make a PNP transistor in active region. Using the symbol is like this. So PNP transistor is represented by the arrow which is going inside. And active region is used to amplify the signal. Now let us see what are the various transistor currents. Now here the base to empty junction is forward biased and collector junction is reverse biased for the NPN transistor, and this is for the PNP transistor. Also the empty junction is forward biased and the collector junction is reverse biased. That means this is in the active region. Now let us see, when you apply a positive voltage, the majority charge carriers are holes in the p-type emitter. So they are repelled by the positive voltage and they are made to enter the n-type base. So when they enter into the n-type base, in n-type base the majority charge carriers are electrons, but it is lightly doped. So some of the holes are lost because of recombination, so we get a small amount of base current. Now the remaining holes, the remaining holes are attracted by the negative terminal of the battery and they are injected into the collector. So the remaining holes are collected by the collector and they travel towards the negative terminal of the battery. So this is the direction of currents. So the positive terminal of the battery, it repels holes, so you get a emitter current in this direction, and some of the holes are lost because of recombination in the base region, and we get a small amount of base current here, and the remaining holes, they reach the collector and the collector current direction is this way. So in the transistor, the emitter is heavily doped and it is of moderate size. The base is lightly doped and it is very thin. The collector is doping is the collector is less doped compared to the emitter, but it is much more than the base region doping, and but its size is large. So the emitter is heavily doped and it is large in size. The base is lightly doped and it's very thin. The collector is moderately doped and it is bigger. Why? Because the collector has to accumulate more number of charge carriers and the collector is used for amplification. So if you have more area, there can be a better heat dissipation and the collector will not get heated up. So always the collector is made of more area compared to the emitter. So emitter is heavily doped compared to the collector, and base is very thin and it is lightly doped. So this is the direction of currents for the PNP transistor, and NPN transistor, the direction of currents is opposite compared to the PNP transistor, but working is same. And of course the battery polarities are also they are reversed. Now let us see in more detail for the PNP transistor. So in PNP transistor, when we apply a positive voltage, what happens? The base to emitter junction gets forward biased, and in case of diode, we have already studied that whenever a PN junction is forward biased, the depletion layer gets reduced. So we get very thin depletion region because the emitter junction is forward biased. Because this junction is forward biased, so the depletion layer width it decreases. On the other side, the base to collector junction is reverse biased. So what happens? The depletion layer width is more because the junction is reverse biased. So when the emitter junction is forward biased, what happens? The holes which are here, they are pushed towards the base. So when they are pushed towards the base, what happens? Some of the holes they meet with electrons, and the electron hole pair it constitutes the base current, and remaining holes they reach the collector because there is a positive, there is a negative terminal here. So remaining holes they reach the collector terminal. So if you see the barrier potential, you can see here the barrier potential is like this because here you have electrons and here you have holes. So this is how the barrier potential is going to be here. But here in the case of base to empty junction, because it is reverse biased and there are more number of charge carriers, negative ions here. So it comes down further. The barrier voltage height is more in the case of collector. So let me repeat once again. When positive terminal is connected, then the holes which are the majority charge carriers in the emitter region, they are pushed towards the base region, and some of the holes are lost due to the recombination in the base region, and that constitutes a base current. And remaining holes, they are pushed towards the collector region because here we have a negative terminal, and that constitutes major current. So that is called as the collector hole current. Now let us see how the transistor construction is done. So the transistor is constructed in three ways: grown type, alloy type, and diffusion type. The fourth one is the epitaxial type that we will discuss later. So there are three ways of constructing the transistor, or there are three ways of building the transistor: grown construction, alloy construction, and the diffusion method. So what is a grown construction? So in grown type, it is made by drawing a single crystal from a melt of silicon or germanium, and whose impurity concentration is changed during the crystal drawing operation. So as the crystal is drawn, relevant impurities are added, and the impurity concentration also is changed during the crystal drawing operation. And in alloy type, a thin wafer of germanium is taken, N-type germanium is taken, and two small dots of indium are made to the sides, and it is temperature is raised to a very high value. So then the indium melts and it dissolves and it forms the p-type region, because indium is a p-type dopant. So n-type dopant is taken, on two sides we have made p-type material, which is nothing but the indium, and the temperature is raised, so we get p here, and this is n. So this is a PNP transistor formation in alloy type construction. You can see here this region is made high, is made more because the collector area is more, because it has to collect more number of, it has to collect amplified signal. Next, let us see the manufacture of grown junction transistor. So grown junction transistors are manufactured through growing a single crystal, and which is slowly pulled from the melt in the crystal growing furnace. And the purified polycrystalline semiconductor is kept in the chamber, and it is heated in the atmosphere of nitrogen or H2 to prevent oxidation. Okay. Then a seed crystal is attached to the vertical shaft, which is slowly pulled at the rate of 1 mm or 4 hours or even less. So the seed crystal initially makes contact with the molten semiconductors. So the crystal starts going as the seed crystal is pulled. So to get n-type impurities, we add dopants like phosphorus or arsenic. Okay. And when the crystal grows n-type semiconductor, as now the crystal grows in N-type semiconductor, then P-type impurities are added. So now the crystal is P-type. So this is how this NPN transistor is fabricated. Now let us see the principle of operation of BJT, and let us have the comparison between the diode and the transistor. So what is a diode? It is a semiconductor device in which current flows only in one direction. So that is the diode. That is why we call the diode as a switch. Okay. So this is anode and this is cathode. Okay. And a transistor is a device which transfers a weak signal from the low resistance region to the high resistance region. That is why it is called as transistor, transfer resistor. So it transfers a signal from a weak region, that is from a low resistance region to the high resistance region. That is why it is called as a transistor. And transistor, a diode uses rectification, and a transistor, it is used for regulation, amplification, and rectification. And there are only two terminals in the case of diode, whereas in the case of transistor, there are three terminals: emitter, base, and collector. And diode switch is uncontrolled, transistor switch is controlled. Because there are three terminals, the third terminal we use for controlling purposes. So types we have junction diode, we have light emitting diode, we have photodiodes, Schottky diodes, tunnel diodes, varactor diodes, and Zener diodes. There are various types of diodes. Whereas in the case of BJT, we have bipolar transistor, field effect transistor, and of course we have the MOSFETs, etc. And the region we have P-type region and N-type region for diode. For transistor, we have emitter, collector, and base. So what are the advantages of BJT? The advantages of BJT are it has very high speed of operation. So it can operate at high frequencies, and it has high driving capability. It can supply more current, and it can be used as a digital switch. So that is why when we design logic circuits using MOSFETs, the basic logic is designed by the MOSFET, but to improve the output driving capability, transistors are added on the output stage so that they can drive more load, they can supply more current. So the advantages are the BJT has high frequency of operation, it has high driving capability, and it can be used as a digital switch. So with this, I conclude today's session on the principle of operation of BJT. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.